Hello, everyone. It's Jessica Parcell, and we are in week 4. And we're going to take a look at identifying whether events are independent or dependent on each other. So we're deep into probability. Okay, experiment 1. A deck contains 12 cards numbered 1 through 12. A card is randomly selected and reinserted into the deck. I'm going to circle that. The deck is then shuffled, and then another random selection is made. Okay, event A. So let's say you have these cards numbered 1 through 12. 1, 2, 3, 4. All right, you step up to the deck, and the chances of getting a 3, of course, are 1 out of 12. There's only 1 3 in here. Okay, now the second event, we want to determine if that event is dependent on this first event or if they are independent of each other. And your key to knowing whether they're independent or dependent is the reinserted part. So if this 3 was taken out, let's say it was taken out, but then it was put back in, right? You are going to start again with all 12 cards, and the chances of getting a 6 at this point is 1 out of 12. So the probability didn't change. So that means that they are independent events, right? Drawing a 6 doesn't depend on whether or not you drew a 3 because you put the card back into the deck. Now, if you had taken that card out and thrown it away, then we would be having a dependent situation. Okay, experiment 2. Raphael randomly selects a sock from a drawer containing black socks and brown socks and puts the sock on. I'm going to circle that. Then another random selection is made from the remaining socks. Determine whether these events are independent or dependent. So his first event is he chooses a black sock. The second event, he chooses a brown sock. Well, these events are depending on each other because right here, he put the sock on. So let's just say Raphael, this is his drawer. Let's just say this is his sock drawer, right? And he's got black, 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 black socks, and brown, 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 brown socks. Okay, so let's say he gets a black sock, right? Well, getting a black sock is 4 chances out of 8 total socks in the drawer. But he puts this sock on, so now that sock is no longer in the drawer. So the chances of getting a brown sock are 4 out of 7 socks left. So selecting brown totally depends on what happens with that first draw, which was pulling the black, because Raphael put it on. Now, if he had put the sock back in the drawer, these would be independent events, just like with the experiment in A. Okay, a family has two children. The older child has red hair, and event B is both children have red hair. Okay, so let's say they have a baby 1, we'll call this, and it has red hair, okay? And then event B would be they have another baby 2, right? And this child has red hair. Well, in order for both of them to have red hair, baby 1 had to have had red hair. If it didn't, then event B would not be possible. So event B totally depends on whether event A, the first child, has red hair. Side note, I married my husband back in 2000. He has red hair. I was hopeful I was going to get red hair children. I did not. I got dark hair children. So marrying a ginger does not necessarily mean you will produce ginger children. All right. That was a little side note for you. Experiment 4. So we have a number cube. They always call it a number cube. It's a die. We all know that, right? It's got six sides to it. Okay. So event A, they roll a 4. Well, if you have 1, 2, 3, 4, 5, 6 options, and you roll a 4, that's a 1 out of 6 chance of that happening. Now, the second event is rolling a 2. Well, when you roll a die, there's no memory, right? There's no memory. That die does not care whether or not you rolled a 1 or a 6 or anything. It starts over. So when your probability resets itself, okay, it resets itself, that means that they are independent events, okay? Rolling a 2 does not depend on whether or not you rolled a 4 on a previous roll. All right, hopefully this is making sense. Last one. A litter of puppies consists of black puppies and white puppies. Okay, so let's just make a little box of puppies here. Let's say you have, well, let's see if I can get that right there. So let's say they have black puppies. Let's say you have 3 black puppies and 3 white puppies. A puppy is randomly selected and removed from the litter. Then another selection is made. Okay, event A. The first selection is a white puppy. Okay, so we know that there's a 3 out of 6 chance of getting a white puppy. Now, if they remove the white puppy from the puppy box, the chances of getting a black puppy are 3 black puppies, but out of 5 total. So see how that probability changed? If probability changes like that, it's probably going to be dependent, right? Because selecting a black puppy is going to totally depend on if they selected a white puppy and remove it from the puppy box. All right, we'll see you in the next video. Hopefully this was helpful.